Okay, this is our video explanation of solving a polynomial inequality. It's our second one. We did one yesterday. The big difference today is that there is a greater than and equal to sign. I also tried to throw in all the little tricky parts that there could be. So instead of just giving you a straightforward one, I tried to throw in some things that would make this a little bit harder. So in green, we have our fully factored equation. You would normally have to do that step. So going from the first line to the second line, you would do all of that and it would take about half of the page. Our focus today is on the second part, how do we actually turn that equation into an answer that we can use. And we're going to do this using a sign table. I'm then going to show you how it matches up with a graph, and you can choose to use the sign table or the graph from now on. You don't have to use one or the other, but you have to know how to turn it into an actual answer at the end. So once we have our factors, we're going to state our zeros. So our zeros here are going to be -1, 1, and 2. And if those were the only zeros that I stated, I missed one. And the reason I didn't put it up right away is it's very easy to miss. This little x here, sometimes written at the front, just beside the -3, so it would be -3x, and then everything else, actually is a 0 at 0. So you have to make sure you include that one. It will mess up your entire sign table if you forget it. So everything will be off and you won't get the right final answer. So we have our zeros, and the first thing we did yesterday was rewrite them in order from left to right, so that when we do the sign table, everything is in the correct order. So we're just going to rewrite the exact same numbers in ascending degree underneath. Because there is this equal sign here, we don't just want when it's greater than 0, we want to include when it is equal to 0. We have to include these 4 zeros. The 4 zeros are going to be when it's actually equal to 0. So we want to make sure that whatever our final answer is includes -1, 0, 1, and 2. So in order to remind yourself of that, you can actually just put a star right here and say include in final answer. And I would do that right on my question when I was answering it on a test or something. Put a little star and say include in final answer. And the reason is this greater than or equal to, that equal to part. It's kind of hard to emphasize that. That little part is the important part because it includes where the zeros actually are. As far as how to set up our sign table, it's no different. If there was a less than or greater than equal to, that doesn't matter. It just matters for our final answer. So we're going to take this information and put it into a sign table like we did yesterday. Along the top, we have all of our factors. The -3 is new. Yesterday we just had factors. We didn't have a leading coefficient there. Here we do. So it gets its own column, just like that. Just the -3. And when you get to this point, it's very important when you do that x minus 2 factor that you remember the squared. So if you forgot to write, right here, if you forgot to write that squared, it would mess up your sign table because it changes whether it's positive or negative. So that's really important that you get all the factors written out exactly the way they are at that green step. And we're going to take all the factors along the top, and then on the left, we're going to divide our graph into a bunch of intervals from the left and the right of every 0. So we look at our lowest 0 here as the -1. So we go to the left of that -1, and then between each set of zeros. Okay, and we just realized that we forgot one of the factors, so we're going to add x minus 1. And while we're at it, we're going to add our last column here for the entire function. Once we set up the sign table, we've done the hard part. It's usually worth it to go back and check so that you've got all the factors. So that's good, we've got all the factors, and we want to check that each of our intervals over here sort of match up with one another so that we end up covering the entire domain of XER. So in the end, it should go all the way from -infinity to infinity, and we should have all the little pieces in between. Once we do that, we're now going to choose a number in each interval and sub it into each of the factors. So for the first interval, we're going to choose the number between negative infinity and negative 1. We don't want to choose the negative 1. So if we choose that negative 1, when we get to this factor, we would end up with an answer of 0, which is neither positive nor negative, so it would mess up our sign table. So we don't want to actually choose any of the factors. We want to choose in between the factors. So probably in this first interval, I would choose negative 2. So then in your head, you're going to go across and sub negative 2 in for x. The very first column has no x. So if we're looking at this column, we have no x there. So the answer for that factor is always going to be negative. So we could actually just go ahead and put negative in for every single spot. And if we wanted, while we were at it, we could also put positives in for this entire column, because whenever you square something, it has to be positive. So you don't have to do that like that, but you can kind of skip ahead a little bit and fill in that entire column. Now we're, again, going to take our negative 2 that's in the first interval and sub it into x plus 1. So in our head, we would do negative 2 plus 1, which gives us a negative number. Negative 2 is our x, so it's just negative, and negative 2 minus 1 also gives us a negative number. And we will continue like that all the way down this example. So the next thing we're going to choose is a number between negative 1 and 0. And I chose this specifically for this practice question because there is no whole number you can pick. You have to use a decimal or fraction in that interval. So I told you yesterday, try and choose a nice easy whole number unless you can't. Here we can't. We have to choose probably negative 1/2. So anything in that interval will work, but negative 1/2 is the easiest. It's still pretty easy to do in our head. So negative 1/2 plus 1 will be positive, negative, and negative. Okay, so then we have numbers between 0 and 1. 1/2 is probably what we're going to choose. So positive, positive, and negative. 1.5 is probably what we're going to choose in this next interval. So positive, positive, and this last one will all be positive. Once we have our sign table all filled in, we're going to go across each row. We can think of it as counting up the number of negatives, and if there is an odd number of negatives, it will be negative, and an even number of negatives, it will be positive. You can think about it as a negative times a negative times a negative times a positive times a negative gives you a positive. Or you can think of it as every two negatives cancel each other out. So however you want to think of that, as long as you know how to do it to get the right sort of answer at the end. So the second row has 1, 2, 3 negatives, which will be negative. The third row has 2. And the last two have 1. So we get this table. Now we're most of the way there. Most of your marks for the question would have already been granted. So you already have, say, 6 out of 7. But that last mark is going to come from knowing how to take that table and put it into a final answer. And typically there are a lot of problems at this point. This is sort of where, if you're not really understanding what's going on, this is where it's going to show up. So we want to make sure that we look back to the question here, where we have greater than or equal to 0, which tells us we need to take all the situations where we were positive. So if it said less than or equal to 0, we would circle the other options. That's really important, so that we go back and check that step. So we only want when it's greater than or equal to 0, which is going to be here and here.
Please excuse this interruption. Would all participants...
All right, so now we have to put these intervals together. Because it was greater than or equal to, we want to use square brackets instead of circle brackets. And because it was greater than or equal to, we need to make sure that we include all of those zeros in our final answer. So let's go through and start writing this out. We're going to have negative infinity to -1 with a square bracket. We don't typically put a square with infinity ever. I would never take a mark off for that though. So it makes sense to me, whichever one you want to choose. Just typically we use round brackets for infinity. And our answer is going to start off looking like this. We won't worry about trying to put those two intervals together because the edge doesn't match up. So the -1 and the 0 aren't like bumping into one another. So we don't have to worry about putting those two together. But we do have to go back and check this idea that -1, 0, 1, and 2 have to be included in our set of final answers. So we have this first interval from -infinity to -1. So -1 is included in that one. We also have this set that goes from 0 to 1. So 0 and 1 are included in that. But the 2 isn't included anywhere. So we have to just tack it on to the end. Say we also need to include when x is equal to 2. And that is our final answer. Everything between -infinity and -1, including -1, everything from 0 to 1, including 0 and 1, and the number 3 all by itself. I will very quickly just show you what the graphs look like for this. So on the left are my two original graphs. This was the original question right here. We wanted to know when the red graph was bigger than or equal to the blue graph, and it matches up to what we said as our final answer. So if you took your time and looked at that, it would match up to our answer. And on the right, I've now put the green graph on top. So the zeros of the green graph should be where the red and the blue graph intersected one another. And you can even see what happens here at 2, that we have that little spot where it's just touching. And I think maybe, yeah, that's why it ends up looking like. So I think this was greater than 0. Just don't worry about that equation. The graph does match our equation that we had. So our equation was up there, right here, does match. So I will put that full document if you wanted to see those graphs on the website. If you wanted to print them off or just see them again, you don't need the graphs to answer the question. You can fully answer the question just using algebra.